Hello, this is section 8.1, Simplifying Expressions with Roots. Part 1, Roots. Recall from our discussion of exponents. For any real number x and any natural number n, x to the n is repeated multiplication of x with itself n times. For example, x to the second power, read x squared, is x times x, and x to the third power, read as x cubed, is x times x times x. On the other hand, a number which produces a specified quantity when multiplied by itself a set number of times is called a root. For example, 4 is the square root of 16 because 4 squared equals 16. We denote this as 4 equals the square root of 16, or just radical 16. And we say 4 is the square root of 16. As another example, 2 is the third root of 8 because 2 equals the cubed root of 8. We denote this as 2 equals the cubed root of 8 and say 2 is the cubed root of 8. In general, we denote roots by y equals the nth root of x, where n is the index and tells us how many times y is multiplied together to get x. In the above notation, n is called the index and x is the radicand, which is found under the radical symbol. When n is an even number, there are two possible roots. For example, -4 times -4 equals 16, and 4 times 4 equals 16. So the square root of 16 equals -4, and the square root of 16 equals 4. To avoid confusion, we will assume the nth root, where n is even, denotes the positive root. For example, the fourth root of 81 is 3. Additionally, if n is even, then the radicand must be non-negative. In order for us to evaluate it to a real number. For example, the square root of -4 is not a real number. Example 1. Match the following roots and numbers to make true statements. The square root of 36 is 6. The cubed root of 27 is 3. Notice the negative is on the outside of the square root for this one, so this is saying the negative of the square root of 81, which is -9. The fifth root of 32 is 2, and the cubed root of -8. Since 3 is odd, we can take the cubed root of -8, which is -2. Part 2, Simplifying Roots. Notice that exponents are roots naturally connected by the following property. For any integer n greater than or equal to 2, if n is odd, then the nth root of a to the n is a, and if n is even, then the nth root of a to the n is the absolute value of a. One thing I want to talk about is why this is true, because a lot of people think the square root of x squared equals x. But if these two things were true, that means that any number we plug in will give us the same output. But if we plug -3 in, this becomes the square root of -3 squared, which is the square root of 9. And from what we said above, this is +3. But if we plug -3 on this side, it just becomes -3. These two things are not equal. That's why we need to put absolute values here, because then that becomes an absolute value, which then becomes an absolute value, in which case these two things are equal. So that is why when n is even, you need an absolute value sign. Simplify the following roots. The cube root of 64, that's 4, because 4 times 4 times 4 is 64. The fourth root of 81 is 3, because 3 times 3 times 3 times 3 equals 81. The square root of 144 is 12, because 12 times 12 is equal to 144. Negative square root of x squared. Because this is even, this will be the absolute value of x, and because of the negative sign, it'll be negative the absolute value of x. The square root of m to the sixth. Now, you can either write this as the absolute value of m cubed, or the absolute value of m quantity cubed. The third root of b to the ninth, that will be b cubed. Now, the reason why I don't need absolute values here are because this is odd and not even. And then why is it b cubed instead of like b to the sixth? Well, that's because b cubed times b cubed times b cubed. So again, we got it 3 times, is b to the ninth. Square root of 16n squared. Well, this is where you can take the square root of the number and variable separately. So this becomes 4 absolute value of n. One thing I do want to point out in the homework, there are going to be some times where they say assume the variable is positive. So if it says assume variables are positive, then 4 times this absolute value of n is the same thing as 4 to the n. Cube root of 64p to the sixth, well, that'll be 4p squared. And then negative the fourth root of 81 q to the 28, well, that'll be 3q to the seventh, and then negative. And that is it for section 8.1.